In this video we have another optimization problem that we want to solve. It's a maximum minimum type situation. This is the last problem that we will solve without having to use Lagrange multipliers. The playlist, by the way, is at the website digital-university.org. If you go down to the calculus playlist, click on that and then scroll down to where it says applications of derivatives, you find the series here on maximum minimum problems. What we're going to do in this video is consider this kind of a situation. Let's say that you are standing on one side of a riverbank. You are here. The distance across the river is 3 miles, and you want to end up over here where this distance is 12 miles, and you are able to row across the river at 2 miles an hour. You're able to run at 6 miles an hour. So the question is, what is the fastest way to get from here to here? Would it be to just row across the river and then run the 12 miles here, or should we just row all the way across the river and not run at all? So to set this up, so these would be our two extreme possibilities: either rowing all the way across and doing no running, or rowing directly across and then run the remaining distance. The intermediate type situation would be if we rowed to some intermediate point, so that this distance, say, is x, and then ran the remaining distance. That remaining distance, of course, would be 12 minus x. So let's set the problem up like that. If we consider it in those terms, the total distance the expression for that would be this diagonal, or this hypotenuse really, plus this distance, which is 12 minus x, and this hypotenuse would be 9 plus x squared, the square root of that. So 9 plus x squared. That's the distance that we are rowing across the river, going from here to here. Then for running, it will be 12 minus x. And maybe x will turn out to be equal to 0. Now if x equals 0, then that means we just row directly across, then run 12 miles. Or x might turn out to be equal to 12, meaning that we just row directly across, or some intermediate value. Let's see if we can find out. This is the total distance. Now the total time, let's write that in. That's the distance divided by the velocity. So this is, we're rowing across the river, that distance, that many miles, at 2 miles an hour. So it'll be this divided by 2, or 1/2, the square root of 9 plus x squared, plus 12 minus x, that's this distance, that's our running distance, and we can run at 6 miles an hour, so it'll be that distance divided by 6. So the way we have the problem set up, this is our expression then for the total time. Now again, if x equals 0, then that means we go directly across and then run 12 miles. Or if x is equal to 12, then that means we just row all the way across. So let's see what we have. This is the expression for time. We want the minimum time. So we do that by taking the derivative of time with respect to x and set it equal to 0 to determine the critical values, just like we did in the other videos. Now to do that, let's write this in exponent form. Okay, we're going to take the derivative of this expression with respect to x. So bring the 1/2 down. That is 1/4. Then here we have 9 plus x squared. The new exponent is 1/2 minus 1, minus 1/2, times the derivative of what's inside, that is times 2x. And then here, the derivative of this with respect to x is going to be minus 1/6. That equals 0. So let's solve for x. Here we have 2 divided by 4, so that is x. And let's put this down in the denominator, the square root of 9 plus x squared. And we have minus 1/6 equals 0. Let's just do the subtraction. We have 6x minus the square root of 9 plus x squared divided by, oops, we should have a 2 down here. This is 2 divided by 4. This is 2 to give us a 2 here. And we multiply these together, that will be 12 times the square root of 9 plus x squared equals 0. So multiply through by this times 0 is 0. It goes away here. This equals 0, so that means 6x equals this quantity. So we have this expression. And then we can square that. So we have 36x squared. 36 times x squared equals 4 times 9 plus x squared. We have 36x squared. Here we have 4x squared. Bring it over here, it's minus 4x squared equals 4 times 9. That's 36. So we have 32 times x squared is equal to 36. So x squared equals 36 divided by 32, or x will equal, get things in better focus. Here we had, from here 32 times x squared is 36, so there's x squared. Now let's take the square root. That will be plus or minus 6 divided by the square root of 32. The square root of 32 is 4 times the square root of 2. Now, let's go back to how we set our problem up. X can be 0 or x can be 12. There is no negative value for x. So we'll discard this. So x equals 6 over 4 times the square root of 2, or we can rationalize this if we want to. And then x equals 6 times the square root of 2. 2, that's 8. Or that would be 3/4 times the square root of 2. So the critical value for x is 3/4 times the square root of 2. So let's go to the top here. Let's write that in. X equals 3/4 times the square root of 2. That's our critical value, meaning that it makes the derivative of t with respect to x equal to 0. So it's either going to be the maximum amount of time or the minimum amount of time. And we don't know. Now, the way we solved this part of the problem in the previous videos was to take the second derivative and then plug in the value for the critical point and to see if that gave us a positive or a negative expression for our second derivative. With this problem, we can determine whether this is a maximum or a minimum value for the time by considering it from this point of view. The minimum value that x can have is 0. The maximum value that x can have is 12, and this is in between those two values. So what happens, say, if x equals 0, how much time does that take? And we say x equals 0, that means then that we're going directly across and then running the 12 miles. So x equals 0. And we should first write down, which we just erased, our equation for the time. Time, remember, was the square root of 9 plus x squared divided by 2 plus 12 minus x divided by 6. Okay, x equals 0, meaning we're just rolling directly across and running the 12 miles. So the time then would be that 0, square root of 9 is 3, so we have 3 over 2, x is 0 plus 2. So that's 7 halves, or that's 3 1/2. So when x equals 0, time equals 3.5. Now here we have 3/4 times the square root of 2 for our critical value of x. This expression is very close to 1. It's like 1.06. So we're just going to round off our critical value to 1. So for the critical point, when x equals 1, the time will be the square root of 10 over 2 plus 12 minus 1 is 11 over 6. And when we do that, we get 3.41. So here, our critical value for x is very close to 1. 3/4 times the square root of 2, we have time equals 3.41. Now the other extreme value that x can have is to be 12. Now, when x equals 12, now that means then that the distance here is going to be 12 minus 12. 12 minus x, 12 minus 12 is 0, meaning that we're just rolling all the way across to this point. And how much time does that take? So x equals 12, t will equal the square root 144 plus 9, that's the square root of 153 divided by 2 plus 0, and that's about 6.18. So when x equals 12, time equals 6.18. So just by doing these little comparisons, the way the problem was set up, these were extreme values for x, being 0 and 12. This was in between them, and we saw that this, in fact, gives us the minimum time out of any of them. So, in fact, this value for x, then that gives us, this would be just about 1 mile then. 1.06 miles. So the fastest way to get across then would be row to here where we're at 1.06 miles and then run the remaining approximately 11 miles, and then that will give us then the fastest way to traverse that distance. Okay, I guess that's it for this video then. Join us in the future videos. We're going to consider more problems like these. They're going to be more complicated, and we'll see what a powerful tool then that we can have by using Lagrange multipliers.